Hi, team. Um, I promised you that I would look at question 12 from page 196. It's the chapter 3.5 in the textbook today, and give you some insight on that. So let's go ahead and we'll take a look at that right now. So we've been asked to create functions that are equivalent to this function here, f of x is equal to 8 raised to the power x. So first, let's just get a good visualization of what it looks like. So y-axis, sorry, the x-axis will be its asymptote, and it's going to be really, really tiny over here. And it's going to start showing up about there, and then it's going to hit the point 0, 1, as all of these parent exponential functions do. The point 1, 8 is going to be part of it. And it's going to grow extremely fast because that's a really big exponential base. And it does that way off to infinity real quickly. So that's what their function looks like. And they want us to create functions that are the same. One of the ways that we can do this is with exponent laws, and the other way is with transformations. Oh, and they want the function to have a different base exponent, but there's also other ways to do it with other transformations and a values. But I'll let you play with those on the test because it's a thinking question. So you have to think. Okay, but here, one of the things that I could do is I could say, well, I could reflect that. I could create a new function that was like a reflection of this in the y-axis. And it would look like this, and it would grow like that, and then down here. And that would just be like with a negative x. But this is also the function. I kind of recognize that this would be like g of x is equal to 1 over 8 to the x. Okay, that's also, this is exponential decay. This is exponential growth, 8 to the x. This is exponential decay, 1 over 8. All right? And that's a different base. And it's the same. It's the same function. Well, no, it's a different function. It's like this. But then if I just reflect that in the y-axis, how do I do that with a negative k? So then I could have a new f of x, which is the same thing, but we can call it h of x, whatever. It's equal to 1 over 8 to the negative x. Okay, and that is the same function as this. It's exactly the same. Want me to prove it to you? Okay, let's go to Desmos and we'll prove it to ourselves. Let's graph y equals, f of x equals whatever, 8 to the x. It goes so fast. Watch this. Whoa, that's like almost a vertical line. And then let's do 1 over 8. Put it in brackets. To the power x. Oh, wait, right. That's a reflection in the y-axis. But I also know that I can reflect things in the y-axis by using negative. Oops. I'm not attached to there. It is. There, negative x. There. Look at that. Same thing. It is the same because it's the same. So let's take a look at y. Algebraically, it's the same. You might say, this is pretty awkward. Let's get rid of that negative. So h of x is equal to, let's just evaluate the negative exponent. Well, we'll split it up. 1 over 8 to the negative 1 to the x. This is equal to 8 to the x. Okay, it's the same thing. It's exactly the same algebraically. It's exactly the same when we graph it. It will produce the same table of values. Now, as one way of doing it is just with your knowledge of k transformations. And because you've been practicing so many exponential decay and exponential growth, and every time you see one of these functions, you visualize it, you can do that. That's what I've been asking you to do. But if you haven't been visualizing it every time, it's harder for you to make those leaps. So I can understand. Now, let's take a look at another way we can do it. We know that 8, okay, I can write, I'm just going to start from f of x here. We're going to just go in blue. F of x is equal to 8 to the x. Well, isn't that exactly the same thing as saying f of x is equal to 2 to the 3? Because that's 8 to the x. And then 3 times x, so f of x is equal to 2 to the 3x. It's the same. Let's graph it and prove it to ourselves. 2 to the 3x. It's the same because it's the same because it's the same. It's the same table of values. It's the same graph. It's the same algebraic function. You just got to do your different stuff. Okay. So they asked for different bases. These are all different ways to do the same function with different bases. What about the different writing of the same function with the same base? This is actually a little harder to do. We're going to need an A and a D transformation. Okay. I'm going to say, what if? Okay. I'm going to work with this. This is my, let's just work with this. I'm going to turn these ones off. And I'm going to say, we'll call this f of x is equal to this. Okay, I haven't changed it. I just wrote it down as f of x. We're going to create a new function. G of x is going to be a transformation of f of x. But I'm going to shift x over to the right by, let's say, 3 points. Okay, so we're going to move this over in the positive x direction by 3. So I'm going to go minus 3. There it is, moved over by 3. And then I'm just going to multiply all of the outputs by 64. Work? Right. Why am I not right? What did I not do right? Let's 8 to x minus 3. So I need to. Why is that not the same? Now I'm super confused. What do I need? Oh no, that's x to the 2. That's 8 to the 2. 8 to the 64 is. Sorry, 8 to the 3 is 512. Watch this. 512. Oh, it's the same. It's because it's the same. It's because it's the same. Okay, why is that the same? I'll show you. Let's do a different one. If I did x minus 1, it's going to be more apparent to you. Okay, watch this. Okay, that's a D transformation of 1. So this point here, 0, 1, moved over here to 1, 1. Okay, I'd like that point 1, 1 to actually map to 8. So if I multiply to 8 by 8, boop, it actually now is back to the same function. Another fun thing that you'll notice is that this point over here, which was, oops, I got to get on the red one. This is my f of x. Negative 1 is 1/8. This is 1 over 8. Okay, negative 1, 1 over 8. And that moved over here to 0, 1 over 8. So if I multiply that by 8, it's back to this point. Okay, so there. With an A transformation and a D transformation, I can create the same function. Pretty cool, eh? These exponential functions behave in very interesting ways when we start transforming them. Don't you wish we had more time to spend on exponential functions? Well, that's why you've got, grade 12 staring you in the face when you graduate from my class. That's why you will continue practicing with these. But these are all just the things you can discover by playing in Desmos, which is something I heartily encourage you to do. Let's take a look at algebraically why those two are the same. Okay, so I suggested that if I have a new function g of x, let's say, is equal to 8 multiplied by 8 to the x minus 1. I suggested that that would be the same thing as f of x equals 8 to the x. That was your given function, which is equal to g of x. Let's prove that that's true. Okay, let's work on this here. 8 to the x minus 1. This is equal to 8 times 8 to the x times 8 to the negative 1. Okay, this is my backwards product of a power rule. X to the a times x to the b is equal to x to the a plus b. So here I had x minus 1, so this is the same thing as 8 to the x times 8 to the minus 1. 8 times 8 to the minus 1 is 1. I just moved this, I flipped it bottom of the fraction and put it underneath that one. This cancels, it's 1. Equals 8 to the x. It's the same. Okay, so that's shows you some of the ways that you can play with these exponential functions to simplify more complex functions. I can take this one and I can simplify it, and I can take this one and I can transform it to different ones that are in fact the same. I could do that by dividing this. That was just like using product of a power of a power law, and then this one is a product of a power, product of powers law. can transform them. Okay, so I hope that gives you some insight. It's going to be an idea that you can apply on thinking portion of the test tomorrow. And if you watched this video, that was good thinking that you watched this video. I hope it was helpful. Okay, bye for now, everyone. I hope your studying tonight is profitable and fruitful. Definitely contact me with any questions that you might have. Bye for now.